Hi, folks. As many of you probably already know, I'm a regular on Jose J.G. Gonzalez's Open Debate show. If you've never seen that show, you should really do so. A few days ago, another regular on Jose's show agreed to debate me on the topic of gravity and whether or not it exists. I spent the time and effort to make a small presentation in anticipation for the debate, but Arwijn did what most flat earthers do and backed out of the debate. So I'm doing the next best thing, and I'm going to make my presentation here on my channel. What you see here is the Laser Interferometer Gravitational Wave Observatory, or LIGO for short. It was designed to detect gravitational waves whose existence was predicted by Albert Einstein. Gravitational waves are very subtle and very difficult to detect, and that is why this monster detector is necessary to detect them. Each leg of LIGO is 4 kilometers long. There's one in Washington State and another in Louisiana. I won't go deep into how LIGO works, but basically it fires 2 lasers at right angles to one another. These lasers return to the detector and simultaneously under normal conditions. If they don't return simultaneously, the cause may be a gravitational wave. Since other factors can cause this phenomena, it cannot automatically be declared to be a gravitational wave. That is why 2 different detectors in 2 different locations are necessary. For it to be declared a gravitational wave, both detectors must register the same anomaly. On September 14, 2015, LIGO detected a gravitational wave from 2 black holes that collided 1.3 billion years ago. 2 years later, the founders of LIGO were awarded the Nobel Prize in Physics. It's also worth noting, and you can see it in the picture, that the far end of each leg is off the ground due to Earth's curvature. So what I have here is called a density tower. And all you need to make one of these is fluids of varying densities. They separate out due to their specific gravity. So let's see what happens if you eliminate gravity from the equation, what this density tower will do.
Let's turn it over to John to see the fluid in action.
Density tower. It's got different liquids, different densities. So right now we're in the microgravity, so they're really separate. So you have F272, water, and vegetable oil. Then as soon as we hit zero, as soon as we go into microgravity, well, you'll see. Zero. Science!
That was a bit tough to see as John started to float away with the tower, but did you see the way it oozed? Let's see it on the next parabola, once John has strapped himself down a bit.
1, 0. Not separating at all.
Now let's talk briefly about what specific gravity is and how you can determine it. So specific gravity, that I just call SG right here, is the ratio of the density of an object to density of water of equal volume. For example, ketchup has a density of 1,400 kilograms per meter cubed, while water has a density of about 1,000 kilograms per meter cubed. So if you do that math there, you can see that you end up with a number 1.4. There's no units to specific gravity because the units are identical up here, so they just divide out and cancel. If you want to know if something is going to float in water, then this number will tell you that. If the number's greater than 1 or equal to 1, the object won't float. If it's less than 1, then it will float, and you can tell how much it will float above the water. If the numbers, for example, is 0.2, then 20% of that object will be displaced or will displace water. Most flat earthers will tell you that gravity doesn't exist, and the things that attracts objects to the earth is density and buoyancy. Well, here I have the buoyancy equation. The force of buoyancy is equal to the density of an object times the volume of an object times little g. Anybody who's not a flat earther knows that if you multiply anything by 0, then the answer is going to be 0. So if you want buoyancy, you have to have gravity. The mountain that you see behind me is known as the Halen Mountain. It's in Scotland. It was the site of a famous experiment that came to be known as the Halen experiment in 1774 and then was repeated in 2005. The way that they performed this was they took a plumb bob that under normal circumstances will hang straight down, and they took it part way up the mountain and put it in close proximity to the mountain. The thought was that if the mountain exerted some sort of gravitational force of its own, then the plumb bob would deflect slightly towards the mountain. That is what happened, and it was used to actually estimate the weight of the Earth. I could go on forever talking about what gravity is and how we can prove that it's real, but I don't want this video to get too long. I did think it would be interesting, though, to see what Arwin's response was to my arguments, since he won't debate me. So I sent him a little sneak preview of it, and his response was, well, I'll show you. I can show you easier than I can tell you.
You can't push me this way. Stop pushing me this way. I can't stand it anymore. I can't stand it. Stop talking about it and do something! Kill them all! Now! Slice her open! Finger, stop him, end it, end the curse! End it! Now! You can't wait anymore! You can't do it! You have to stop him now! Get your goddamn shotgun, whatever the fuck you got, knives, and just go to them and freaking kill them all! Now!
To the flat earth.
Wow. I had no idea that my video was going to be that impactful. Folks, if you think gravity's real and that Arwin should take his meds, then please like and subscribe, and I'll see you soon.